Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 3 of lesson number 1, atoms and molecules. So as we just studied in part 2 with respect to what exactly is an atom, what is the size of an atom, what is atomic radii, what are the two different laws of chemical combination which have been given, right? Because both the laws were given, that is law of conservation of mass and law of constant proportion. Both the laws were stated, but there was no theoretical proof for it, right? There was no theoretical proof uh, which can specify or which can conclude both the laws. So for that, Dalton came into picture. Now we even discussed about John Dalton in the last part, right? And we discussed that John Dalton, he was born in a very poor family, he was born in a weaver's family. Then further, he started his teaching career at the age of 12. Then later he became the principal. After that he went to Manchester and he started teaching chemistry, physics, and maths to college students, right? And then further, he was even working on his research project. And while doing so, he came up with the atomic theory, which has given a way to, you can say, which has provided a way to study on more about matter, more about atom, because that is what matters, right? That was very important at that moment. So Dalton came into picture and he gave six different postulates, which we today know it as atomic theory. Okay, so now we will be discussing on the postulates of Dalton's atomic theory. We have already discussed that in the last class, and I hope every one of you now you will be able to explain them in your own words as well, right? So we will be starting with the further part of the lesson. As we just discussed about that, we will be discussing about atomic mass and all today. But before that, I want each one of you to please revise whatever you have taken note of in the last class, and then we will be even going through the slides one by one, so that you have a good idea, you have a proper idea on what exactly we were discussing in the last class. Because if I start with it, I want you all to be proper and be you should be informative about whatever we are studying, and you should be even able to explain whatever we have studied till now. So that kind of confidence you should be having within you now. Okay, so I hope every one of you have started revising whatever you have written in your book. So I'll be showing you the slides one by one where we have discussed more about atoms, what exactly atoms are. We have discussed on two different laws of chemical combination, which includes law of conservation of mass, and the second law that we have discussed is the law of constant proportion, which we also call it as law of you can say definite proportion, right? And Proust was the one who has given that law. Then we have discussed on Maharishi Kannad, and there were many different chemists who were working towards it. Okay, so we started this lesson atoms and molecules by discussing on some of the ancient Indian and Greek philosophers, right? And the Indian philosopher that we discussed was about Maharishi Kannad, because he was the one who started postulating about matter, which we know it as padartha. And when that has been when we divide it further, there will be a time where like we are going to obtain the smallest particle beyond which further divisions will not be possible. So he named those dividing matter as Parmanu. So that Padartha was named as Parmanu further. Then we have Indian philosophers named Pakuda Katyayama, who has elaborated the doctrine and has said that particles normally exist in combined form, because of which like various forms of matters have been observed. So around the same era, there were like different ancient Greek philosophers as well, named Democritus and Leucippus. Now, this Democritus and Leucippus, they have even suggested that as we go on dividing the matter further, there will be a stage which we are going to obtain where the particles will not, like, we cannot divide them further. Okay. So I just want each one of you to please go through it once. After this, we discussed more about Democritus, because Democritus like called all the indivisible particles as atoms, and like the meaning of the word atom itself is indivisible, right? So all these statements that were given was like, all you can say this were all philosophical consideration, and there was no experimental work which were done to validate the statements, to validate the, you can say, the statement given by all the Greek and the Indian philosophers. Okay, but this was only till 18th century. After that, further, after the like at the end of 18th century, all the scientists, they have recognized the difference between elements and compounds, and they became interested in finding out how the elements combine and what exactly happens when they combine. Okay, so Antony Lavoisier, he has laid down the foundation of chemical sciences by giving us two important laws of chemical combination, which we know it as law of conservation of mass, and the second law that we know it as law of constant proportion or law of definite proportion, right? So I just want you all to go through the slide once. So this is the law of chemical combination, like whatever rules that have been given, they are the rule that like which are very important and which has laid down the two important law of chemical combination, where the first law that we have is law of conservation of mass. So this law of conservation of mass states that mass can neither be created nor be destroyed during a chemical reaction, right? And we can explain this through an activity. If you all remember the activity that we have discussed, through that activity we were able to conclude that the, you can say, mass of reactant is equal to mass of product, right? Because there were many different kinds of you can say chemicals that we have added in, like one chemical, a group of chemical in a test tube and another group of chemical in the beaker. So we have to like weigh them individually first, and we have to take a note of it. After that, we have to mix them purposely as such that both the chemicals get mixed with each other, right? So in that case, you will find out that the mass of the product again will remain the same. So accordingly, we can like state the law, or we can like validate experimentally the law of conservation of mass. Okay. So this is the activity that I'm discussing about, and I want each one of you to please go through this activity once. I hope everyone is going through this. Okay, so after that activity, we have the second law that is known as law of constant proportion, which can even be called as law of definite proportion by mass. So I just want each one of you to please go through the slide as well. So your Leviosa along with other scientists, they were trying to come up with this second law to experimentally prove this law of constant proportion, and you're they were successful even doing that. So here we have in a compound such as water, we have the example of water and ammonia which has been given. So water, when it comes to compounds such as water, the ratio of mass of hydrogen to the mass of oxygen is always 1 is to 8, right? So it means mass of water, that is 9 gram of water, when we decompose that, it has been formed of 1 gram of hydrogen and 8 grams of oxygen. That is how we get this 9 grams of water. Okay. Then we discussed on like John Dalton, as I stated that he was born in a poor weaver's family, right, in England, and he began his teaching career at the age of 12. Further, he became principal, right? He became a school principal, and then he went to Manchester to teach mathematics, physics, and chemistry in school, where he spent most of his time teaching students and doing his research work. And finally, in 1808, he presented his atomic theory, which was turning point in the study of matter. Okay. After this, like these are the six different postulates of Dalton's atomic theory that we have discussed, where he have stated that all matter is made up of very tiny particles called atoms, and this atoms, they participate in chemical reaction. Okay, then we discussed that atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. This is actually the law of conservation of mass, because this statement of Dalton is supporting law of conservation of mass, right? Then atoms of given elements, they are going to be identical in mass and chemical properties, and if the atoms are of different elements, they will have different mass and different chemical properties altogether. Okay, then we have fifth point as atoms combine in the ratio of small whole number so that they can form compounds. And the last statement, like the last theory that Dalton postulated, is the relative number and kinds of atoms are constant in given compound. Now the sixth postulate that you can see is supporting the law of constant proportion, and the second postulate that you can see that atoms can neither be created or destroyed in a chemical reaction, that is supporting the first law, that is law of conservation of mass. Okay, so I just want each one of you to please go through this theory, because this is a very like these are very important for us. So I just want each one of you to please go through it once. After this, we discussed on what is atom, so I just want each one of you to please go through it. Okay. After that, we discussed on like how exactly big our atom, like the size of the atom is also plays an important role, right? So here we have like they have been stated that atoms are very small and they are smaller than anything that we can imagine or compare it with, right? So there will be like more than millions of atoms which have been stacked together, and that is how a sheet of paper in front of you is made up of. Okay. And when it comes to atomic radius, we measure the atomic radius in nanometers, where we know like 1 divided by 10 raised to 9 meter is going to be 1 nanometer, and 1 meter is 10 raised to 9 nanometer. Okay. Then we even discussed on like because of the technological advancement now, we can be even like able to produce some of the magnified images of the surfaces of elements showing atom, right? Now we will be discussing on like what are the modern day symbols that we use for an atom of different elements. Okay, so Dalton was the first scientist to use the symbols for elements in a very specific sense, And when he used a symbol for an element, he also meant a definite quantity of that element. That is one atom of that element. Okay, so Dalton, he was the first scientist to use the symbols, and this is how, if you can see, these are some of the symbols, the list of some symbols which was like used by Dalton. Okay, so Berzelius, he suggested that the symbol of elements be made from one or two letters of the name of the element. So when it comes to a circle and a dot in it, it's hydrogen. If it's completely like blank, it's oxygen. If it's grayish, it's carbon. If it's sulfur, it's like a kind of positive sign in it. If it is just I, that becomes the iron. Then S written in the circle is silver, L is lead, C is copper. Okay, the gold symbol is totally different. Then you can see like these are the different symbols which were used by Dalton to make like the identification of the elements easier for him as well as for others, right? But after that, like Berzelius suggested that the symbols of the elements be made from one or two letters of the name of the element. Why to use a symbol? Just take the like name of the element, like let's say for hydrogen we can represent it as H, for carbon we can write it as C, for oxygen we can write it as O, for phosphorus we can write it as P, for sulfur as S, iron as I, copper as C. But here there's a confusion again, like carbon is also starting with C and copper is also starting with C, phosphorus is also starting with P and platina is also starting with P, right? Then we have sulfur and silver, they're starting with S. So what was done, like initially all one letters were like taken, like for carbon we will take it as C, but for copper it will become as Cu. Okay, so like there were different changes which were made further, but you should be even knowing like how exactly it started. When you watch a movie, right, when you watch a movie, you need to know what has happened initially, right? And then you come to know the climax, you enjoy the movie, right? So same way, like how this, or like you can just imagine that you're studying a movie on atoms and molecules. So this is how it all started, where Dalton came up with the symbols. And now, like you might have seen like the symbol of hydrogen, we use them in all daily life, right? Oxygen, carbon, we know carbon dioxide, how it is written, carbon monoxide, and there are so many different elements in picture now. But initially, because there was not much knowledge, this is how it all started with. Okay, so I just want you to write some of the basic points from here, and even if possible, you can just write like the symbols which were used by the Dalton. Just have a note of it in your book. I hope everyone is writing the symbols and everything. I hope you all have taken a note of it. Now see, in the beginning, the names of elements they were derived from the name of the place where they were found for the first time, right? For example, the name copper was taken from Cyprus. Okay, from where the copper name was taken? It was taken from Cyprus. So some names were taken from the specific color as well. Like for gold, gold was taken from the English word meaning yellow. Okay, and nowadays, IUPAC. Now, the full form of IUPAC is very important. The full form of it is International Union of Pure and Applied Chemistry. Okay, so nowadays, the IUPAC is an international scientific organization which approves name of elements, symbols, and units. Okay, and many of the symbols they like are the first one or two letters of the element's name in English. So the first letter of a symbol is always written as a capital letter as an uppercase, and the second letter is written as a small letter that is in lowercase. So when it comes to an example, now hydrogen we write it as H, aluminium as Al, and if you can see the first letter is capital, A is capital, and the next L that we have is a small, and we don't write both the capitals, both the letter as capital letters. Okay. Then next thing that we have is cobalt. Now cobalt we write it as C and like capital C and small O. So in that case, we don't write both the words capital, right? One is capital and one is small. So symbols of some elements are formed from the first letter of the name and a letter appearing later in the name. So examples are chlorine and zinc. If you can see, we are leaving the second letter and we are using the third one, right? So other symbols have been taken from the names of elements in Latin, German, or Greek. For example, when it comes to the symbol of iron, it is Fe, which is taken from its Latin name ferrum. Sodium, it has been taken from its Latin, like from its name, scientific name natrium, and that is why we write sodium as Na. Then potassium is K from kalium. Therefore, each element has a name and they all have a unique chemical symbol as well. Okay. I hope everyone is taking note of all the important points that we have. I hope everyone is writing the examples as well, and these are some of the rules that you should be knowing, because while you write the name of the elements further, okay, they are going to help you out a lot, and that is very important as well. Okay. I want you all to even write the full form of IUPAC, that is International Union of Pure and Applied Chemistry. I hope everyone is writing it. I'm focused more on the slide, because here we have certain important points mentioned. So I want you all to please go through it properly. I hope everyone is clear with all the points which have been given over here on the slide, and you won't be following the same mistake of writing every letter of the element capital, like for hydrogen, because we represent that singly, right? Because like there's only one letter that we use to represent it, but if there is two different letters, we don't write that in capital. The second letter will always go in lowercase. It is always going to be small. Okay. After this, like we have the symbols of some elements which have been given. Like see, we have like many different elements which have been given, starting from aluminium. Now aluminium, we don't represent it as singly A. Okay, we write it as A, and the second letter is L. And if we can have a look over there, like it's the lowercase which has been used. So first word is going to be the capital one, and the second word will be small. Okay, next element that we have is argon. Now argon, may A is capital and R is going to be the small one. Okay, then barium, B capital, A small. Boron, we are just going to represent it by B. So because there is only one single letter which has been used, okay, so boron is written as capital B. Then bromine is Br, calcium is Ca, carbon is C, chlorine is Cl, and cobalt is Co. That is how we used to represent it, all the elements and the symbols. Okay, so I just want each one of you to please go through all the elements and the symbols basically. Okay. I hope everyone is going through the element, and as see they have stated below, do not bother to memorize all in one go. Slowly and steadily you will learn. You will come to know what is the difference that we have between calcium, carbon, chlorine, cobalt, and copper. Okay, just go through the table and you can even write few of the important parts. I hope everyone is going through all the symbols. Okay, after the symbols, we have the next topic to discuss, that is atomic mass. Okay, so see, the most remarkable concept that Dalton's atomic theory proposed was that of the atomic mass. So, according to him, each element had a characteristic atomic mass, right? The theory could explain the law of constant proportion so well that scientists were prompted to measure the atomic mass of an atom, right? So, since determining the mass of an individual atom was a relatively difficult task, relative atomic masses were determined using the law of chemical combination and the compounds which have been formed, right? So, let us take the example of a compound, that is carbon monoxide, which has been formed by carbon and oxygen. How is carbon monoxide formed? By carbon and oxygen, and it was observed experimentally that 3 grams of carbon is going to combine with 4 grams of oxygen to form carbon monoxide. So in other words, carbon combines with 4 by 3 times its mass of oxygen. Okay, I hope you all are going through this slide as well. Now, after this atomic mass, now see, suppose we define the atomic mass unit, which were earlier abbreviated as AMU. AMU stands for atomic mass unit, but now, according to latest IUPAC recommendation, it is now written as U only U, and we read that U as unified mass. So this unified mass is equal to mass of one carbon atom. Then we will assign carbon an atomic mass of 1 U, and oxygen will have an atomic mass of 1.33 U. Okay. However, see, in the first statement they have stated that earlier we used to use we used to use the value as AMU, that is atomic mass unit, but now we use it as U, that is unified mass. Okay. However, it is more convenient to have these numbers as whole number or as near to a whole number as possible. So while we are searching for various atomic mass unit, scientists initially took 1 by 16 of the masses of an atom of naturally occurring oxygen as a unit. So for considering this 1 by 16th of the mass of an atom, there were two different reasons for that. Okay, and the reasons are like oxygen reacted with large number of element, and because it reacted with large number of element, they form compound. Okay, and this atomic mass unit gave masses of most of the element as whole number, and that is the reason that 1 by 16th mass of the atom was chosen. Okay. However, in 1961, for an universally accepted atomic mass unit, carbon 12 isotope was chosen as the standard reference for measuring the atomic masses. So your one atomic mass unit will be equal to, like, one atomic mass unit is a mass unit which is equal to exactly 1/12 the mass of one atom of carbon, that is 12. Okay, so the relative atomic masses of all elements, they have been found with respect to an atom of carbon 12. Getting my point, everyone? So I just want you to write about the atomic mass unit and that unified mass and everything that you find important on screen. I hope everyone is writing all the important points from the screen, as we have many other important points which have been given on screen. Okay. So I hope everyone has like written all the relevant and important point from the screen. Now we will be studying more about the atomic masses in the next class, and even we will be discussing on like how do atoms exist. Okay, and after discussing like how exactly atoms exist, we will be completing with the atoms part, and after that we will be like starting our study on molecules. Okay, because there are two different important concepts which are been given in the lesson, right? So we will be discussing on what is a molecule. We will be discussing on molecules of elements in detail. We will be discussing the atomicity of some elements, the molecules of compounds. Then we will be discussing on what is an ion. After that we will be discussing on many point with respect to like what are the rules for writing the chemical formula, because there are so many elements which have been present, right? And writing the chemical formula, for writing that chemical formula there are certain rules that we need to follow. Then we will be discussing on the formulae of simple compounds as well, and after that we will be discussing on molecular mass and mole concept in detail. Okay, then we'll discuss on formula, unit, mass in detail. After this we have mole concept to discuss in detail, like what exactly mole is and how can we calculate the mole of different elements. After that we will be discussing on relationship between mole, Avogadro's number and mass. Okay, we will be discussing on the relationship between all, and we will be like even discussing it with respect to some of the examples. So we have like 3 to 4 examples which have been given one by one, and this is how we will be ending up with the lesson like atoms and molecules by this summary discussion. Okay, and after this we will be discussing on like summary discussion where we are going to have some of the exercise questions as well to discuss. So I'm going to show you the exercise questions one by one. I want each one of you to please go through them properly so that you can answer them easily further. I hope everyone is going through the question. I hope everyone is going through the questions. So here like while we will be discussing on the formulas for writing the chemical you can say chemical formula, here we have the question on it like we need to write the chemical formula for the following compounds which have been given. Then the next question that we have is writing the names of the elements which are present in the following compound. So here we have to write the name of the element like quicklime, then for hydrogen bromide, for baking powder, for potassium sulfate. These are the names of the elements for like these are the names for which we need to write the name of the elements. So this is how we will be ending up with the lesson atoms and molecules, okay? And I hope whatever we have discussed so far in the lesson till this part, you're very much clear with it. Now the rest of the part, whatever has been left for the lesson atoms and molecules, I will be continuing that in the next part. But I hope like all the basic parts that we have started, like we are almost on an and like on the we will be like ending with the atoms part in the next part, and we will be like starting with molecule as well. So I hope whatever we have studied so far till now, you are very much clear with it. Now the rest of the part for the lesson, I will be continuing that in the next class. Thank you everyone.